folks, so today we're going to be talking about how do we take a slope, how do we take a point, and put those two things together to give ourselves the equation of a line. Believe it or not, you can actually do it, and by the end of today's videos, you'll hopefully have a good understanding of how to do it. So, before we get to there, let's just do a little bit of a quick review and talk about what are these different components that make up an equation of a line. Behind me, I have y equals 1/2 x plus 3. And that's the equation of a line in slope and y-intercept form. Now I know that it's in slope and y-intercept form because I have my y by itself on the left side of the equal sign, I have everything else on the right side of my equal sign, and the number in front of my y is a 1. If I have a y but I have no number in front of it, in math that number is understood to be a 1. If I have an equation in slope and y-intercept form, that's really nice for me to work with if I'm graphing my equation. And the reason why that's nice is because we can figure out what our slope is really quickly. We can figure out what our y-intercept is really quickly. If our equation is not in this form, it's a little more complicated to get that information. But in this form, we can tell what it is just by looking at it. So our slope, which we represent by the letter m, is always the number that's in front of x. Slope is a number, not the x. So slope is 1/2 in this case. And our y-intercept, which we represent by the letter b, is always the number that's added or subtracted at the end. If there is no number there, the number is understood to be a 0, but our number is a 3. Once we have our slope and once we have our y-intercept, it's really easy to draw the graph of our line. So on our graph, we always have a y-axis and we always have an x-axis. If you have trouble remembering which one is which, remember that your y kind of has a vertical stick going down and we have a vertical line going here. So my y-axis is my up and down one. To draw ourselves the graph of our line, we want to follow these steps. Our y-intercept is 3. So what we need to do is, because it's the y-intercept, we're going to go on our y-axis, look to where the 3 is, and draw a big dot right there. Our slope is 1/2. Now that does not mean that we're going to look at any of these numbers down here and do something at the 1 and the 2 or the 2 and the 1. But what that does mean is we're going to look at our dot that we've just drawn on our y-intercept. We're going to go up 1 box and right 2 boxes. Up 1, right 2. Now if you want to draw the graph of a line, all you need are 2 points. I could just draw a line through these 2 points right here. To make it a little bit more accurate though, I can go from this point and find myself another point on that line using the slope. So my slope is always 1/2, so I want to go up 1 box over 2, up 1 over 2, up 1 over 2. If I want to go backwards, if I want to go from this box to this box, I need to do the exact opposite. I need to go down 1 and left 2. So I can go down 1, left 2, down 1, left 2, down 1, left 2, and so on. Since we're drawing the graph of a line, we need to make sure that our line is actually there. Always use a ruler or a straight edge to help you with this. And because it's a line, we know that lines continue on forever. So to show that they continue, even past the points that we've drawn, we just put little arrows at either end of our line, just to show that that line actually continues. So great, we've drawn the graph of our line. If the question was just asking us to draw the graph, we'd be good. But let's actually explore this a little further, because I know in class a whole bunch of you have had questions of why is there a y in that equation and why is there an x in that equation? What do they actually mean? So to help you out with that, let's go through a few examples. This x is telling me if I choose a value for x, so whatever that x value is, I plug that into this equation. The y over here tells me what the y value is that matches that x. So for example, if I choose an x value of 4, I would plug a 4 into this equation. And the y value that I would expect to get would be the matching y value that falls on this line. So let's see if that works. If I plug in x value of 4, does my y value work out to be a 5? So I'm going to say let x equal 4. And I'm just picking any value of x. Usually it's nice to pick a value of x with a y value that falls directly on our grid line that we have here. If I look at 4, 5 matches up really nicely on that grid, so we're just going to check to see if that actually works. Let x equal 4. So I have y is equal to 1/2. Since my x is 4, I'm going to replace the x right here with a 4. Plus 3. So y equals 1/2 times 4 is the same thing as saying 4 divided by 2. 4 times 1 divided by 2, which gives me 2 plus 3. Y equals 5. So now what I do is I say, okay, my x value is 4. My y value is 5. So the point that we're given is the point 4, 5, which is what we were expecting to find. Let's just check something on the negative side. Let's see what happens if x is equal to negative 4. If x is equal to negative 4, what we should expect to get as our answer is that y is going to be positive 1. I'm going to say let x equal negative 4. So 1/2 times negative 4 plus 3. Well, 1/2 times negative 4 is saying the same thing as what's negative 4 times 1 divided by 2, which is negative 2. We have our plus 3. Negative 2 plus 3 gives us positive 1. So if x is equal to negative 4, the x value that we chose up here, y equals 1. And so our point is negative 4 and 1, which is exactly this point right here. So really what this equation is telling me is it's telling me if I plug an x value into here, I'm going to get a y value that falls on this line. If I do my math and I get a y value that's different